Hey guys, Mr. McKinney here, just going through the last videos in the area and volume unit. So today we're going to be dealing with volume, and we're dealing with what's called known cross sections. And this is a common type of problem to see on the AP exam. So when we deal with the volume of known cross sections, basically we're saying as we integrate across the x-axis or the y-axis or some other axis, at each point we know what the area is going to be. So in this case, the area is a square. So you'll have some function a of x that tells you what the area of the shape is. You might have a square or a triangle or a semicircle, and you're going to be putting a bunch of those squares together to create a three-dimensional solid or a volume. The formulas are pretty straightforward. So we're going to go ahead and do both of them on the same slide. So this is what we've been referring to as the sideways method, this bottom one. So if you look at these formulas, in both of them, I would have written it as v equals the integral from a to b, a of x dx. This is the formula that I would memorize. Or v equals the integral from c to d of a of y dy. So the area of the cross section is just the only thing that goes inside the integral. You don't have pi on this one unless you're dealing with circles or semicircles or something like that. You're just adding up the area going across the axis. So you're adding up a bunch of squares or adding up a bunch of triangles or whatever. The hard part on these types of problems is figuring out what to use as your a of x function. Now, on the AP exam, sometimes they'll just give you the a of x function. But for most of the problems on MathXL and in this lesson, we're going to have to figure out what the area is. The AP exam will do it both ways. Sometimes they'll give you a function a of x. Sometimes they'll tell you it's a square and you'll have to figure out the function for a of x yourself. So let's take a look at this first one. In the region bounded by f of x equals the square root of 25 minus x squared and the x and y axis in the first quadrant, find the volume if the cross sections are squares perpendicular to the x-axis. All right, so let's draw a picture and figure out what we're even talking about. So y equals the square root of 25 minus x squared. This is going to be a semicircle, but we can't really see it yet. So let's square both sides and then add the x squared over. So this is really x squared plus y squared equals 25, which is a circle with a radius of 5, and the center would be 0, 0, since I don't have anything added or subtracted to y. Now, we're only dealing in the first quadrant, and we're also bounded by the x and y axis. So if we think about our picture, we've got a circle with a radius of 5 and a center at 0, 0. So there's my function. Now, technically, f of x would include this left half also. It would not include the bottom half at all because we have the positive root. If we had the negative root, we'd have the bottom half of the circle. I'm not looking at the part that's in quadrant 2 because it tells me that we're in the first quadrant. So this is the base, and then each cross section, so the areas are going to be coming out of the page essentially. So we're going to be drawing squares. So this is the base of the square, and then it's kind of hard to draw three-dimensional, but you can imagine that that's the square coming out of the page. And then we've got another square coming out of the page. And then we've got another square coming out of the page. So we've got a bunch of squares adding up as we go from along the x-axis. Okay, now we said the formula is going to be the volume is equal to the integral from a to b of a of x dx. Since we're perpendicular to the x-axis, and whatever axis you're perpendicular to is what you're adding up going across. So I'm going to be adding up going across the x-axis. So if you're perpendicular to the x-axis, this is like a straightforward problem. If you're perpendicular to the y-axis, that's going to be one of the sideways problems. So perpendicular to the x-axis or any horizontal line, you're going to use this top formula. Perpendicular to the y-axis or any vertical line, you're going to do the bottom formula. Okay, now we need to know what the area is. So we've got squares. In general, the area of a square is side squared. Now each side is going to be my function, f of x, because that's going to be the distance from the x-axis to the function. So my a of x, excuse me, my a of x function in this case is just going to be f of x squared. So a of x is going to be the square root of 25 minus x squared. Square root and squared are going to cancel out. So a of x would just be 25 minus x squared. So now I can plug that in. My limits are going to be x values. We started at 0, and then since we had a radius of 5, we're going out to 5. So I'm going to do the volume is the integral from 0 to 5. My a of x function was 25 minus x squared dx. Now this particular problem would be fairly straightforward to do without a calculator, but we've done plenty of integrating, and at this point I want to focus on setting it up because that's the most important part. So let's go ahead and just jump to our calculator, and if we type that in and hit math 9, we're going to get 83.3 repeating. So again, you're just going to need to figure out a formula for the area. In this case, it was just a square, so you have to figure out where the side is. The side is just f of x in this case, and then we're going to square that. All right, let's look at a few more examples. So we've got the exact same setup here. We've got the same region bounded by that function. The difference is the cross sections are going to be isosceles right triangles. We're still perpendicular to the x-axis. So I've got that same picture as before, but this time I'm going to be creating isosceles right triangles. Isosceles tells me that two of the sides are the same. Right tells me that I have a 90-degree angle here. Now, we're going to assume that the base of one of these is going along the base of our region here. And the AP exam will be much more specific. I think MathXL does a better job as well. So anyway, this is my base. The base here is essentially the function, the distance f of x. Now, instead of drawing a square at each time, I'm going to be drawing a triangle. Now, it's really hard to draw three-dimensional right angles, but we've got isosceles right triangles with these two sides the same, filling it out. Now, again, the important part is just to figure out what the area is. Normally, it's 1/2 times base times height. In this case, the bases and the height, or the base and the height, are the same. So we can just say it's 1/2 b squared. And my base, we said, was f of x. So the a of x function on this one is just 1/2 times f of x squared. So we're going to set it up almost exactly the same. We're still going to be going from 0 to 5, a of x dx. Now, the only difference is when I plug it in, I'm going to have 1/2 times my function squared. Again, we can do it on the calculator, but really we can just pull this 1/2 out and we can see that it's just going to be half of our previous answer. So 41.66666 repeating forever. On the AP exam, you can either say 41.666 or 41.667. So again, the important part is just figuring out how do we set up the a of x function. Then we're just going to integrate like we have been. And at this point in the unit, the focus should be on setting them up, and then you can use your calculator to work them out. All right. In the region bounded by x squared plus y squared equals 4, find the volume if the cross sections are semicircles, cross sections with diameters perpendicular to the x-axis. All right. Now, sorry about that. All right. So we've got a circle here, and we've got a radius of 2, square root of 4 is 2. And again, the center for this one is at 0, 0. Now, we're not bounded by the axes at all, and we're not bounded by being in the first quadrant. So on this one, we're going to have the entire circle. So circle with a radius of 2. At each point, we're going to have semicircles coming out of this region. So this is going to be the diameter of a semicircle. Let me actually try to draw that with a different color, see if it makes it a little bit easier. So we've got a semicircle, another semicircle, another semicircle, another semicircle. So we've got semicircles coming out of the page. So we need a formula. Now, real quick, we're going to need a function. Since we're perpendicular to the x-axis, we're going to want our function to be in terms of x. So let's solve for y. X squared plus y squared equals 4. So y squared equals 4 minus x squared. So y equals positive or negative square root of 4 minus x squared. Now, the positive square root of 4 minus x squared is going to be on the top here. The negative square root of 4 minus x squared is going to be on the bottom. Now, what we're going to be able to do for a semicircle, let's think about that. A semicircle is half of a circle. So the formula for a semicircle's area would be 1/2 pi r squared. So I need to know what the radius is in order to come up with an equation for a of x. Now this y, I'm going to rewrite it as a function, and now I'm just going to pick the top half because I'll be able to do it with just the top half, and I'll show you how that's going to work. So f of x would be the square root of 4 minus x squared, so it's this top half here, which means it's the distance from the x-axis to the semicircle on the top. That is my f of x. That f of x is also going to be the radius of this semicircle, because at each point, the distance from here to the top of the circle is the radius. So the function ends up being the radius. So this one ends up being not too bad since those two things line up. Now again, we're always going to say that the volume is a of x dx. My a function in this case is going to be 1/2 pi times f of x squared. My limits, this time we have to go all the way over and start at -2. So my volume will be going from -2 to +2. 1/2 pi f of x squared, and my f of x was the square root of 4 minus x squared with respect to x. Square root and squared cancel out, and I can pull this pi over 2 out front if I was going to do this by hand. So I'd have pi over 2 out front times the integral, square root and squared cancel out, so it's just 4 minus x squared dx. This is how we would be doing it by hand, but again, at this point, we can just go ahead and plug it into our calculator. So we get that the volume is 16.755. All right, let's see if we can get one more in that's fairly similar to this one. It's got the same setup. All right, so we're still in this circle. This time we're going to have equilateral triangles that are perpendicular to the x-axis. And actually this one's going to take a little while to set up. So we're going to go ahead and end this first video and we'll pick up here on the second video. There's just going to be a couple more problems, this one and then a sideways problem on the second video. Hope this was helpful.